right, today we're going to do transformations of exponential functions. We're going to take a new function, the exponential functions, and we're going to shift it around. So first let's look at the parent function. And it's interesting for exponential because we really can have many different parent functions depending on what the base of the exponent is. Most common ones to see are 2, 10, and e. E is a number we haven't really talked about a lot yet, but it's just a number kind of like pi. It's an irrational number. It's approximately 2.718, around there, but it keeps going. So just know that these are the common bases that you're going to see, and the transformations will be based on one of those three for the most part for our transformations. So I'm going to use the base of 2 for this example. So if I plug in -3 in for x, that is going to give me 1/8. If I plug in -2 for x, that's going to give me 1/4. If I plug in -1 for x, that's going to give me 1/2. 2 to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. And 2 to the third power is 8. So this will give me an idea of what the exponential graph is going to look like. If I graph these, -3, 1/8, -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4, and last 3, 8. So we can see the exponential graph is going to look something like that. So whenever we graph an exponential function, you'll notice our domain is going to be all real numbers because this graph is going to continue all the way to the left to infinity, negative infinity, and this graph is going to continue on and on towards positive infinity. So for our domain, it will always be all real numbers, or negative to positive infinity. Our range, however, notice we have an asymptote here. This graph, if I keep going in this direction, it's going to get closer and closer and closer to y equals 0, but it will never quite reach it. That's the definition of an asymptote, a line that the graph approaches but never touches. So when we talk about the range, the lowest this graph is ever going to go is it's going to be approaching 0, but it is never going to reach it. So I'm going to put a parenthesis so we know it's not equal to 0, but it is going to get very close to 0. Then, how high is this graph going to go? Well, it's going to go on towards positive infinity. For exponential functions, we always will have one asymptote, and that asymptote in this graph is at y equals 0. Now, let's talk about the different transformations that can happen from this parent function. All right, here's the possible transformations we can have. A, remember, always, when it's negative, it will reflect the graph down over the x-axis, so that's one possible transformation for the A. Also remember the A is our vertical stretch or compress. So it will stretch this graph skinnier, or it will compress it to make it wider. The B is different for exponential. It is just the base of the function. So the most common ones you're going to see are 2, 10, and e. And depending on this, if it's 10, this will be a skinnier graph than this, because you can imagine if we plug in 1 for x, this is now going to be 10. So it will make a skinnier graph, but it's still just considered the base. It is not a stretch or compress. We just call that the base of the exponential function. H, as always, shifts our graph left and right. So we will take this key point right here and shift it left and right based on that number. Remember, because of the minus, it always moves in the opposite direction of what you'd expect. The K is going to move the graph up and down, just as all the other functions. Notice, though, the K will also be where your horizontal asymptote is. So whatever that number is where this horizontal asymptote will be. Let's try an example. Notice our base is 2. This is going to be our H. And since it moves the opposite direction, this is going to shift our graph right 3. And the 4 is our K. So that's going to shift the horizontal asymptote up 4. So I'm going to shift my asymptote that was at 0 in the parent function. I'm going to shift it up 4. So my new horizontal asymptote is here. The point that I'm going to shift is always 1 above the asymptote. That was kind of like our key point in the parent function. And I'm going to shift that key point to the right 3. That key point is very helpful because I know from this point on it's going to get closer and closer and closer to the asymptote, but never cross it. And from this point to the right, it's going to grow exponentially. It's going to get bigger and bigger and bigger to that side. So my domain, again, is from negative to positive infinity. It's going to continue to go all the way to the negative infinity, all the way to positive infinity for the x values. For the range, the lowest this graph will ever go is it is approaching 4, but it never will touch 4. So at 4, I'm going to put a parenthesis saying it's not equal to 4, it is approaching 4. And then, of course, my graph is growing exponentially towards positive infinity. The last feature of this graph is we have a horizontal asymptote at y equals 4, which will always be whatever our k value is. And notice it's cutting the y-axis, which is how we know it's a y equals equation. We always want to write asymptotes as an equation because it's a whole line, it's not a point. And that's the basics of graphing exponential functions with your transformations. Just practice transformations on the a, the h, and the k. Oh, quit acting like you got something, dude. Brag.
My God.